The models changed overnight. The data coming in right now from the equatorial Pacific is unlike anything most Americans have ever seen. And what it means for your weather, your summer, your region, is something every single person in this country needs to understand. A massive pulse of heat is rising from deep beneath the ocean surface, and it is already rewriting the forecast for the months ahead. In this video, I am going to show you what is happening in the Pacific right now, why it matters to every American, how it is already reshaping this hurricane season and this summer's storm pattern, what the European and American models are telling us about the long-range threat, and why the timing of all of this could not be more critical. This is Arthur here, and welcome to Sky Space Lab. If you are new to this channel, I want you to hit that subscribe button right now, because what I am about to walk you through is exactly the kind of information that will keep you ahead of the weather instead of surprised by it. Let's get into the data. The story begins deep beneath the surface of the Pacific Ocean. Not on the surface where you can see it, not in a model output, but hundreds of meters below the waterline, where one of the most powerful oceanic processes on Earth is now underway. What scientists have been tracking for the past several weeks is a downwelling Kelvin wave. Think of it as a submarine heat train, a massive pulse of abnormally warm water moving eastward along the equatorial Pacific, somewhere between 50 and 250 meters beneath the surface. The latest measurements show subsurface temperature anomalies running as high as 8 degrees Celsius above normal inside that wave. 8 degrees, that is not a seasonal variation. That is not noise in the data. That is a geological scale heat signal moving toward the surface of the ocean, and when it arrives, it will trigger one of the most consequential atmospheric reorganizations the United States has experienced in decades. Here is the critical number you need to remember. The official threshold for El Nino is a sea surface temperature anomaly of plus 0.5 degrees Celsius in the Nino 3.4 monitoring region of the equatorial Pacific, sustained for 5 overlapping 3-month periods. The threshold for a strong El Nino is plus 1.5 degrees. The threshold for what scientists and forecasters call a super El Nino, the rarest, most impactful category, is plus 2 degrees Celsius above normal. As of this morning, NOAA has officially declared that El Nino has formed in the tropical Pacific. The Nino 3.4 index has already crossed plus 0.9 degrees Celsius, nearly double the El Nino threshold, and the data shows it is still climbing. NOAA is already forecasting a 63% chance that ocean temperatures in that region will exceed 2 degrees Celsius by late this year. That would meet the definition of a super El Nino. Let me say that again. A 63% chance of a super El Nino. And that number is conservative compared to what some of the global models are showing right now. The ECMWF, the European model, widely regarded as the most accurate long-range system in the world, has now assigned 100% probability to a super El Nino developing by late 2026. The International Research Institute at Columbia University puts the probability of El Nino conditions persisting through at least early 2027 at 98%. And the Climate Prediction Center here in the United States now calls a super El Nino the single most likely outcome for the coming months. This is not a routine El Nino. The subsurface data is running warmer than the 1997 to 1998 super El Nino did at this same stage. That 1997 event is the benchmark, the most impactful El Nino in the modern observational record, the one responsible for catastrophic flooding in California, the one that altered hurricane tracks and reshaped the global weather pattern for over a year. And the current Kelvin wave is tracking ahead of where that event was at this point. Most channels are not showing you this part, but it matters. So let's keep going. Before I walk you through the 7-day severe weather outlook, let me answer the most important practical question. What does an El Nino of this potential magnitude actually do to your weather right now, this week, this summer? The answer lies in the jet stream. El Nino forces the Pacific jet stream to shift southward. It extends that river of high-altitude wind eastward across the Pacific and into North America at a latitude that is lower than normal. And when that happens, the entire architecture of the American weather pattern changes with it. In the short term, over the next several weeks, the first signals of that shift are already appearing in the forecast data. ECMWF long-range runs are now showing a stronger El Nino atmospheric signature in the June and July patterns than any previous model run captured. The models are upgrading their understanding of this event in real time. Every new run is coming in stronger. Here is what that means for this week and your immediate forecast. A ridge of high pressure is positioned across much of the central and eastern United States. Heat is building fast. Temperatures across wide swathes of the Central Plains and Midwest are running 6 to 10 degrees above where they should be for mid-June. Afternoon readings from Kansas City to Columbus to Charlotte are pushing into the low to mid-90s through the weekend, with heat index values reaching 105 degrees or higher in the most humid areas where dew points have climbed into the low 70s. Meanwhile, along the storm track, the boundary between that heat ridge and the disturbances rotating down from Canada, severe weather is an active and ongoing threat. The Storm Prediction Center has a slight risk of severe weather in place today across the Central Plains, with the focus on the Dakota and Nebraska corridor. Large hail up to 2 inches in diameter is the primary threat across this area. Damaging wind gusts up to 70 miles per hour are possible, particularly across central and eastern South Dakota and into southern Minnesota this evening. Scattered severe storms are also likely across the Texas Panhandle and into northeastern New Mexico, with additional activity possible across the southeast and coastal Florida through tomorrow. If you are in any of these areas, today is the day to verify your severe weather safety plan, not after the storm is already spinning up. The tornado risk today is running at 5% inside the most favored zone in central South Dakota and North Dakota. Supercells could organize before upscaling into linear segments, and where discrete supercells hold together into the late afternoon, a tornado, possibly a strong one, is on the table. The most critical window is between 3 in the afternoon and 8 in the evening local time. Tell me right now in the comments, where are you located and what does your sky look like this afternoon? Here is how this week evolves day by day. Thursday carries the severe weather risk northward. The focus shifts to the northern plains, and Rapid City, South Dakota is in a zone where a discrete supercell could produce a significant tornado threat between roughly 2 and 8 in the evening. Wind shear profiles look favorable, instability is building through the afternoon heating cycle, and the cap appears weak enough to allow surface-based convective initiation. By later Thursday evening, those storms should upscale into a damaging wind threat spreading northeast towards Sioux Falls and into southern Minnesota. Friday becomes the transitional day. The low-pressure system driving this week's severe weather begins its eastward progression. A broader area is at risk for at least isolated to scattered severe storms, the focus shifting more toward the Midwest, including parts of Nebraska, Iowa, and northern Illinois. The tornado risk on Friday looks lower than midweek, with large hail and damaging wind gusts serving as the primary hazards. I think Friday's setup could produce some of the widest area storm coverage of this entire pattern. Saturday and Sunday shift the threat further east still. States like Indiana, Ohio, and Michigan, areas that saw remarkably little severe weather through all of May, now come into the picture. The Great Lakes corridor should be on alert this weekend. Parts of western Pennsylvania and western New York could also encounter strong to severe storms. Looking ahead to next week, the pattern ramps up again. The Dakota and Nebraska corridor looks active by Monday and Tuesday, as the next trough digs in from the Pacific Northwest. The GFS ensemble and the ECMWF are both supporting an increasing rainfall footprint across the Midwest, a region that has been running well below normal on precipitation through much of late spring. For the drought areas from central Kansas through Nebraska and into Iowa, multiple storm systems moving through a persistent moisture axis could deposit 2 to 4 inches of rainfall in some locations between now and mid-June. The Grand Forks area and surrounding regions could see close to 5 inches total over the next 2 weeks if this pattern verifies. That would be a meaningful step toward erasing the moisture deficit that has been building. I also want to address the broader moisture picture for the week ahead, because this matters whether you're in a drought zone or a flood risk zone. The Weather Prediction Center's latest rainfall forecast is painting a significant precipitation footprint across the central states between now and the middle of June. The heaviest totals are expected across a corridor from central Nebraska through Iowa and into southern Minnesota, areas where the storm track will repeatedly activate that frontal boundary. Inside that corridor, locally 3 to 5 inches of rain over a 10-day period is plausible. For areas that have been watching their soil moisture crash through May, that is significant relief. But where back-building convection develops and storms repeatedly track over the same area, flash flooding becomes a serious secondary concern. I want to be specific about timing, because this is where I think people need to stay alert. The overnight hours, Thursday into Friday are critical for that storm system. As the line of thunderstorms sweeping through the Dakotas consolidates and pushes southeast during the overnight hours, it could maintain destructive wind gusts in the 50 to 60 miles per hour range well into Minnesota and potentially Iowa. Lines of storms lose their tornado threat at night, but their wind threat intensifies. If you are in that zone Thursday night, do not assume the overnight hours are safe. The heat story also deserves its own attention in the 7-day window. Across the southern plains, Texas, Oklahoma, Arkansas, temperatures are not just high. They are being amplified by the same ridge of high pressure that is anchoring severe weather along its northern edge. Dallas is tracking toward triple-digit readings through the weekend. Oklahoma City and Little Rock are right there with it. The combination of afternoon heat near 100 degrees and dew points in the upper 60s produces heat index readings in the 110 to 115 degree range in those metro areas. That is a public health event, not just a discomfort issue. And for the Pacific Northwest, the pattern this week offers genuine temperature relief. The cool air associated with that incoming trough from Canada is keeping temperatures well below normal across Washington and Oregon through the weekend. Seattle and Portland are looking at highs in the low to mid-60s, 15 to 20 degrees below where they should be for the second week of June. The contrast between the Northwest and the Southwest this week is borderline dramatic. But here is where it gets really interesting, and I will show you exactly why in just a moment. Let me give you the full big picture, because this is what the data is actually telling us when you put all the pieces together. The reason this summer's weather pattern feels different, more active, more persistent, more difficult to escape, is because of one fundamental atmospheric mechanism. The super El Nino that is now officially developing is forcing an extended Pacific jet stream. This is a condition where that high-altitude river of wind reaches farther east across the Pacific and hooks into the North American circulation in a way that keeps the storm track alive well into summer, when it would normally retreat northward and quiet down. This is one of the strongest Pacific jet extensions I have seen in the month of June in years. And when that jet stays energized, the storm track stays energized with it. For the central United States, that means the severe weather season does not take its usual summer hiatus. Cold fronts continue pushing south from Canada, meeting the expanding heat and moisture building up from the south, and the result is a persistent corridor of instability running from the northern plains down through the Midwest and into the Ohio Valley. That is the zone I am watching most carefully over the next 3 to 4 weeks. For the southeast, the signal is more complex. A strong cold front is currently pushing through the region, and this front is doing something unusual for mid-June. It is actually reaching central Florida, dropping humidity and producing temperatures that are 10 to 20 degrees below normal. In the mountains of western North Carolina, morning temperatures in the upper 40s and low 50s are likely midweek, in June. For Asheville, for Bryson City, for the communities along the high country, that is the fingerprint of a disrupted jet stream pattern, and it confirms what the data is already showing us about the background state of the atmosphere. But that cool signal does not last. By this weekend, the winds shift southwesterly, moisture pumps back in across the southeast, dew points climb back into the mid to upper 60s, and the region transitions back to active thunderstorm potential. The upper Midwest and Ohio Valley see that process repeating: cold front, storm outbreak, brief cool down, then heat and humidity rebuilding. This cycle is likely to continue through most of June. Now let me address the drought story directly, because this is one of the most misunderstood aspects of a strong El Nino in summer. NOAA data from drought.gov shows that the southern plains have been running moisture deficits for an extended period. El Nino's summer signal for this region is generally wetter than normal. The subtropical jet, which becomes more active as the Pacific warms, steers additional moisture northward from the Gulf and from deep tropical sources. That is the wet side of the El Nino summer equation. But AccuWeather meteorologists are now flagging a separate concern. If the tropical Atlantic remains quiet, which is increasingly likely given the El Nino-driven wind shear suppressing Atlantic hurricane development, the southeast could actually see drought developing in certain windows through summer. Tropical systems that would normally inject moisture into the southeast will not be there, and with the subtropical high anchored over the region during heat domes, that absence becomes acute. The climate has a way of being both generous and punishing simultaneously, and that is exactly what a super El Nino year tends to produce. Let me put this event in historical context, because I think it is essential to understanding the scale of what we may be dealing with. The 1997 to 1998 Super El Nino remains the benchmark for modern El Nino science. That event produced peak Nino 3.4 anomalies of plus 2.3 degrees Celsius. It generated catastrophic flooding across California, triggered severe drought in Indonesia, and fundamentally altered global weather patterns for over 18 months. In the United States, that winter saw dramatic snowfall in the southeast, prolonged heavy rainfall in California, and a remarkably quiet Atlantic hurricane season, all consequences of the same underlying Pacific anomaly. The current event is tracking ahead of where the 1997 event was at this same stage. The subsurface Kelvin wave is warmer. The rate of acceleration in the ECMWF probability tracker went from 22% in March to 80% in April to 100% by May. That rate of acceleration is faster than either the 1997 or the 2015 to 2016 super events. If the models continue verifying, this could become the strongest El Nino in the modern observational record, potentially rivaling the 1877 to 1878 event. What does that mean for the American winter ahead? I want to be clear that winter forecasting in June carries enormous uncertainty. But the pattern that emerges from Super El Nino analogues is fairly consistent. The Pacific jet extends across the southern tier of the United States, bringing an active storm track, above normal precipitation, and a risk of atmospheric river events along the California coast from roughly November through February. The southern states, from Texas through the southeast, typically see a wetter, cooler winter under a strong El Nino. The northern tier of the country tends toward warmer and drier than normal conditions in winter, as the jet stays too far south to push cold air deep into the northern states. Updated just this morning from the NOAA Climate Prediction Center, above normal temperatures are favoured for the southern tier and west over the next 6 to 10 days, while near normal conditions hold across the northern tier. That heat anomaly gradually expands and intensifies as we move through late June and into July, tracking westward and amplifying across the desert's southwest and southern Rockies. This is the El Nino heat dome signal taking shape, and it is going to be very significant for tens of millions of Americans from Texas to California over the coming months. The Pacific meridional mode, a longer period oscillation in Pacific sea surface temperatures, is also in a strongly positive phase right now. That signal, combined with El Nino, is what NOAA's hurricane forecasters cited specifically when explaining the expected hyperactivity of the eastern Pacific season. Warmer subtropical waters, enhanced low-level moisture, and a more active intertropical convergence zone are all products of this combined Pacific state. It is not just one knob being turned up, it is multiple knobs turning simultaneously, and they are all pointing in the same direction. Before we wrap up, there is one more thing you need to know, and this is the part I've been building toward. The Pacific hurricane season is now open, and what is happening on the Pacific side of this country right now is one of the most dramatic stories in American weather. NOAA's updated seasonal outlook assigns a 70% chance of an above-normal Eastern Pacific hurricane season this year. The official forecast calls for 15 to 22 named storms in the Eastern Pacific, 9 to 14 of those reaching hurricane intensity, and 5 to 9 of those becoming major hurricanes, Category 3 or stronger. The long-term average for the Eastern Pacific is 15 named storms, 8 hurricanes, and 4 majors. This is not a mild uptick. This is a potentially historic season in the making. Why? Because El Nino operates in reverse in the Pacific compared to the Atlantic. Where El Nino pumps wind shear across the tropical Atlantic and suppresses storm formation, it does the opposite in the Eastern Pacific. It reduces shear, raises sea surface temperatures above already elevated baselines, and creates a development environment that is unusually favourable for tropical cyclone formation and rapid intensification. The season is already producing. The first tropical depression of 2026 has already formed in the Eastern Pacific and was tracking toward becoming Tropical Storm Amanda. A second disturbance, tracked near Central America and likely to be named Boris if it develops, is already being monitored by the National Hurricane Center. Sea surface temperatures across the Eastern Pacific Development Zone are running 1.5 to 2 degrees above normal. That is the kind of thermal energy that feeds rapid intensification events. The water is warm enough that storms forming in this region can reach hurricane intensity quickly, with relatively little warning. What does your region look like right now in terms of tropical preparedness? Drop your city and your hurricane zone in the comments below, I want to know who is paying attention. Now here is the part that directly concerns Americans who might assume Eastern Pacific storms are someone else's problem. In El Nino years, Eastern Pacific systems do not always go west and fade harmlessly over open water. Historical precedent is clear on this. Hurricane Hilary in 2023 made landfall in Baja California and tracked inland into California, Nevada, and Arizona, dropping historic rainfall in areas that almost never see tropical moisture. Hurricane Otis in 2023 rapidly intensified to Category 5 intensity before smashing into Acapulco. These were Eastern Pacific storms. They affected American territory, and in a super El Nino year, with sea surface temperatures as elevated as they are right now, the risk of a recurving or northward tracking Pacific system is higher than average. But the story gets even more interesting when you add in the Gulf. The current ensemble guidance, and I want to be transparent that we are looking at 10 to 15 day range here, where confidence is limited, has been consistently flagging a potential development window in the Gulf during the second half of June. Multiple members of both the European ensemble and the GFS ensemble are showing low pressure development in the Bay of Campeche and northwestern Caribbean region during that window. Here is why the environment could support something. Wind shear over the Gulf is projected to drop significantly during that same period. The upper level high that has been pumping shear across the western Gulf is expected to shift westward over Mexico, leaving the central and northeastern Gulf in a zone of decreasing shear. Water temperatures across the Gulf are running above normal right now, and a deep plume of atmospheric moisture, visible in the latest water vapor satellite data, is set to stream into that region as the pattern evolves: moisture, warmth, and decreasing shear. Those are the three ingredients that allow tropical systems to organize. The European deterministic run has been showing a scenario where a disturbance crossing Central America could get into the Bay of Campeche around day 10 and then curve northward, pulled by a trough sweeping in from the Pacific Northwest. The GFS has been showing a slightly faster version of a similar scenario. They do not agree on the details. They do not even fully agree on the track. But they agree that the environment becomes progressively more favourable, and that is the signal worth communicating. When GFS and Euro agree on something like this, even at long range, you pay attention. That is the rule in operational meteorology. It does not mean you run the headline. It means you watch it every single day and communicate the signal clearly to the people who need to be ready. I am not forecasting a hurricane hitting the United States. Let me say that plainly. What I am saying is that the environmental setup for tropical development in the Gulf becomes progressively more favourable as we move through June, and the models are picking that up across multiple ensemble members. This is a period to watch. If you live along the Gulf Coast, from southern Texas through Louisiana, Mississippi, Alabama, and the Florida Panhandle, now is the time to make sure your hurricane preparedness is current, your supply kit is ready, and your plan is in place. Not because a storm is definitely coming, because the environment is setting up in a way that warrants attention. We will track this in detail every single day going forward. On the Atlantic side, the contrast is extraordinary. NOAA is forecasting a 55% probability of a below-normal Atlantic season. The official call is 8 to 14 named storms, against the long-term average of 14. 3 to 6 hurricanes, 1 to 3 majors. Colorado State University's Tropical Meteorology Group, one of the most respected seasonal forecast teams in the world, is projecting along similar lines, with El Nino the primary suppression driver. The Atlantic opened June 1st with zero tropical activity. Dry air and hostile upper-level winds are dominating the entire basin, from the Gulf to the main development region near Africa. The Saharan dust layer is thick and well established. This is a textbook El Nino suppression signature, identical to the atmospheric setup observed during the initial months of the 2015 to 2016 Super El Nino, which produced only 11 named Atlantic storms in a season that would otherwise have been very active given the warm sea surface temperatures. But here is the critical caveat, and this is the part you must not forget. El Nino reduces frequency. It does not reduce the intensity of the storms that break through. Hurricane Andrew formed during the 1991 to 1992 El Nino event and caused what would today be well over $50 billion in damage. El Nino seasons can still produce direct hits on the United States, and the Gulf, the Western Caribbean, and the coastal waters of the southeastern United States remain warm enough to support rapid intensification if the right atmospheric window opens. I also want to address something directly. Some viewers have asked, why should I care about the Pacific if I live in the Midwest or in the Mid-Atlantic or in New England? Here is the answer. El Nino does not discriminate by zip code. The jet stream shift that El Nino produces affects the storm track across the entire country. It affects the moisture transport patterns that determine whether your region has a wet or dry summer. It affects the intensity and frequency of heat domes. It affects how quickly cold fronts can penetrate south in winter. When the Pacific Ocean fundamentally changes state, and right now it is changing in a way that rivals the most impactful events in recorded history, the downstream consequences reach every corner of the continental United States. The ECMWF forecast through early 2027. The IRI puts the probability of this event persisting at 98%. What that means is that you're not just watching a summer story. You are watching the beginning of a pattern that is going to shape American weather for the rest of this year and into next. The Nino index is at plus 0.9 degrees today. The models say it is heading toward 2 degrees or beyond. The subsurface data is running ahead of the 1997 event. The jet stream is already shifting, the Pacific season is already producing, and the Gulf is watching. This is the big picture. This is why what is happening in the Pacific right now matters to every single American, whether you live in Kansas City, in Tampa, in Fresno, or anywhere in between. I have been watching this data build for weeks, and I can tell you, the pace of acceleration is remarkable. One final question I want you to answer in the comments below. Given everything I have shown you today, the Super El Nino signal, the active severe weather pattern this week, the early Eastern Pacific season, and the potential Gulf development window, where do you think the biggest weather story of this summer is going to come from? The plains, the Gulf, the Pacific, or somewhere nobody's talking about yet? Let me know your city and your read on this. I read every comment, and these conversations genuinely shape how I cover this channel, because you tell me what matters most in your region. Stay weather aware, stay prepared, and I will see you tomorrow with the latest data. Thank you for being here today. If this breakdown gave you a clearer picture of the force that is shaping your weather this summer, please share this video with someone in your area who needs to know what is coming. Whether that is a neighbour, a family member, or someone you know along the Gulf Coast, these are the conversations that matter before the weather makes them urgent. Hit the like button and subscribe to the channel, because over the next several weeks I'm going to be tracking this Super El Nino signal every single day as the data continues to evolve. I will have updates every time the model picture changes meaningfully, every time the National Hurricane Center upgrades a system, and every time the long-range pattern shifts in a way that affects your region specifically. This is not the kind of story that gets told in one video and then goes quiet. The 1997 Super El Nino dominated weather coverage from the summer all the way through the following spring. If the current event verifies anywhere close to what the models are projecting, we are looking at a similar or longer duration story. I will be here for all of it. Tomorrow I will be watching the Gulf development window closely. The National Hurricane Center's updated tropical outlook drops in the morning, and I want to see what the latest ensemble runs are showing for the mid-June Gulf scenario. I will also be checking the newest ECMWF run to see if the 10 to 15 day Gulf signal is strengthening or weakening with the latest initialization. If anything in the pattern changes meaningfully overnight, I will have that update first thing. The Pacific has spoken, and what it is saying right now is a story that is only just beginning.